Okay, well, we're going to be moving into the special right triangles. I'm going to even use 2 lectures on these. Special right triangles, there's 2 types. There's 2 types. One of them, we're going to call this our 45, 45, 90 triangle. And this is in reference of the angles. So 45, 45, 90 triangle. The other special right triangle, I'm going to call it a 30, 60, 90 triangle. And again, this is in reference of our angles. Very, very important triangles. You guys are going to see this back later when you guys take math analysis, right? Pre-calculus. You guys are going to do the unit circle, and this idea comes back then, okay? You guys are going to be using this. Now, 29, question number 29, some of you might be like, I'm sure Leonzo, you forgot to put the question there. No, it's not that I forgot the question, is that I left that empty to use this for our teaching, okay? So I'm going to use this space to go over our work here. So let me talk about our 45, 45, 90 triangle in this lecture. So I'm looking at the 45, 45, 90. Now, interesting on this, let me use a triangle here, not drawn to scale, but let's call this 45, 45, 90. And let's say I was given one value. I remember Pythagorean theorem. Remember a squared plus b squared equals c squared. We can use that formula when we have a right triangle and I know 2 sides. And I know 2 sides, I can come up with a third side. But what if I only know one side? What if I know one side? Let's say one side here was given. It doesn't matter which one. Let's say, what if I say this side right here, it is 5. And then I want you to find the other 2 sides. So here, I did not give you 2 sides. So you cannot really use Pythagorean theorem just yet. I just gave you one side. Now, interesting on the 45, 45, 90 is that 2 angles are equal. All right, so I ask you, given on based on one side, you should be able to find the other 2 sides, and we will. Interesting, coming back like I was saying, is 2 angles are equal. I remember one day I asked you to list the angles from small to large given the sides. And one thing that we know is because 2 angles are equal, 2 sides are going to be equal as well. Now, the 2 sides that are going to be equal are the 2 sides that make the 90-degree angle. I know there's the hypotenuse, the big side. It's the biggest side, so it cannot be equal to another side. So again, the 2 sides that are going to be equal are the 2 sides that make the 90-degree angle. So guess what? I already solved for one side. This side right here is 5. These 2 sides are equal. So you give me one value, guess what? I can find the other value. Now, I should be able to find for this value. This value right here. I don't know what it is yet, so let me call it x. And x has to equal to something, right? I should be able to solve that. But right now, I'm just going to call it x. But I remember Pythagorean theorem. Pythagorean theorem, I remember a squared plus b squared equals c squared. Remember that one? A squared plus b squared equals c squared. My c was the biggest value, was the hypotenuse. So this was my c, and this was my a. I'm going to call this a and b. So according to our formula, we had 5 squared plus 5 squared is equal to x squared. And yeah, we can do that. We can do Pythagorean theorem as soon as we know 2 values. I know 5 squared is 25. So I have 25 plus 25 is equal to x squared. I know 25 plus 25, right? So I have that 50 is equal to x squared. So x must be the square root of 50. Okay, not that bad. The only thing is that when I type in 50 on my calculator, I get a decimal. And then more likely on my instructions, I'm going to ask you, leave your answer in simplest radical form. Well, we learned at the beginning of this unit how to simplify radicals, right? Radical 50 I'm going to split it up as two radicals. I'm thinking two numbers that multiply equals 50. One of them has to be a perfect square. Some people might say, how about 5 times 10? Well, 5 times 10 is equal to 50, but the 5 is not a perfect square. The 10 is not a perfect square. So no, we're not going to do 5 times 10. Again, I'm looking at two numbers that multiply equals 50, but one of them has to be a perfect square. So in my case, I'm going to say, how about 25 times 2? 25 times 2 is 50, and the square root of 25 becomes a whole number, right? The square root of 25 is 5. So my answer would be 5 radical 2. It's 4x. So let me come back here. 5 times radical 2. Now, what if people might say, well, that was easy. I could have used the Pythagorean theorem because I know these two sides are equal. So technically one was given. We can say technically two of them were given. So I'm gonna say, oh, really? That's fun to say. What if I give you a 45, 45, 90 triangle, but then I tell you this side right here is 10. The hypotenuse is 10. Solve for the other two sides. Well, we could still use Pythagorean theorem. I know Pythagorean theorem said as long as I know two values, I can use it. But I know these two sides, I don't know how big these sides are, but I'm going to call it x. I'm going to use the same letter on both sides because I know they're equal. So I'm just going to say x squared plus x squared is equal to 10 squared. Ah, that's not that bad. Now, x squared plus x squared, that is 2x squared, right? Because we're adding. So that's 2x squared. 10 squared is 100. So 2x squared is equal to 100. Let me divide this by 2. So I have that x squared is equal to 50. That means that x must be the square root of 50. Now I'm not going to go back into how do we simplify because I think we should know that x is 5 radical 2. Now let me show you a shortcut. Let me show you a shortcut. Let me show you a shortcut, but remember, shortcuts are just a way how to get there faster. Rely on Pythagorean theorem if you need to, okay? Rely on Pythagorean theorem if you need to. Now, the shortcut, it says, well, not only we know that these two are equal, but there's an easy way how to go from the small side to the big side. Let me just do it like here. Let me draw the shortcut here. From the small side, from one of the legs to the hypotenuse, I'm going to multiply by radical 2. And if I'm going backwards, I'm going to divide by radical 2. That is going to be easy. So let's see. Let's see if it works. 5 times radical 2? Yeah, 5 radical 2. What if I was to go backwards? 5 radical 2. So here I have 5 times radical 2. And yeah, 5 radical 2. But again, what if I was going backwards? I have 5 radical 2 divided by radical 2. Yeah, it works. Nice. Same thing could be done here, right? Here I'm going backwards, right? So I'm going to go 10 divided by radical 2. Remember how I said before, the one way we can get rid of the radicals is by multiplying top and bottom by the same radical. So that gives me 10 radical 2 over 2, which is better known as 5 radical 2. Yeah, that is what we got. So again, let me show you guys a shortcut. Rely on Pythagorean theorem, but if you're going from one of the legs to the hypotenuse, multiply by radical 2. If you're starting from the hypotenuse and going backwards, divide by radical 2. So let me do questions 30 and 31. It says, find the missing side lengths. Leave your answers as radicals in simplest forms. So here, number 30, what do you have? Do you have the legs or do you have the hypotenuse? The legs are the two sides that meet at the 90-degree corner. No, I don't. I have the hypotenuse. So remember, when you're starting from the hypotenuse to go to one of the legs, let me just say it, I'm going here. I'm gonna go 8 radical 2, the number given, divided by radical 2. When I'm looking for one of the legs, you're starting from the hypotenuse, you're gonna divide by radical 2. Okay, these cancel out, so I get 8. So this side is 8. So matter of fact, let me write this in red. This side is 8. Can I just say this other side is 8? And I'm done. I finished. Remember, the two sides that meet at the 90-degree corner are equal. So as soon as you find one, well, you found the other. Looking at number 31, I can easily solve for y. I'm going to say y is 9 radical 2 over 2. Done. Done for y. If I'm solving for y, done. Because the two sides that meet at the 90-degree corner are equal. Okay, I'll come back on how to type this, okay? I'll come back on how to type this. Now, how do I solve for x? How do I solve for the hypotenuse? Well, when I'm going to the hypotenuse, remember I have to multiply by radical 2. So let me write this in blue. The number that I'm starting with is 9 radical 2 over 2. Remember, that's the number that I'm starting with. And I'm going to multiply by radical 2. So I'm going to put it on top. Usually in the fraction, when we're multiplying, we put it on top. When we're dividing, we put it at the bottom. So now what do I have on top? I have 9 times 2. Remember, radical 2 times radical 2 is 2. So that's why I call it 9 times 2 over 2. These 2's can cancel out, so I just get 9. So x is equal to 9. Y is equal to 9 radical 2 over 2. Okay, I'm not going to go how to type in 9, but let me go over how to type in this fraction. First, I look at the top, 9 radical 2. We've been typing radicals for a while, so 9 radical 2. So I just type in what do I have on the top. That's it, 9 radical 2 on the top. Then I do a backslash. That means I have a fraction. After the backslash, everything that I have under the fraction. So in this case, 2. So that is the 45, 45, 90.